Hey guys, I just wanted to show you a couple of mods that you've probably seen before, some you may not have, of just what I've done to my transmitter here. First of all, I have hardwired my battery lead, this one here, into the port for charging. Normally that's disconnected. Basically there's a diode on the inside of the board, and what I've done is I've made up this little loom here. I've got a Dean's T connector here, and this is the other end of the socket here. That plugs into there like so, and the other end plugs into my battery charger, and that's it. I'll basically plug it in through there, and then my battery, which I've modified, I've put instead of having 8 AA's, I've got two 4.2 or 3.7 volt lithium ion batteries, the rapid fire or whatever they're called. I can't remember what they're called anyway. But anyway, I've actually wired in a, there's no solder on the actual batteries themselves. I've actually super glued them together and then run a bead of hot glue down the centre of each one. So if they ever crap out, I'll just replace the pair as a set, which you should do anyway. And what I've done is I've used the old case that fits in here with the 8 batteries. I've cut the ends off and used the ends as templates for the plates for getting all the circuitry together, which I've got a bunch of pictures that I'll put in here also. And I've also put in a balance circuit. So you've got your 2 earth check circuits here for checking to compare pair in your balance charger, and then you've got your positive that runs through your normal positive side. And then this plug here is the main battery, because I wanted to be able to still pull the battery out if I wanted to or had to. But basically the reason I've done these mods is because I want to do it so that the battery can stay in place. You know, what's the point of pulling it every 5 minutes? Because this little connector in here, this one here that plugs into there, that is just ridiculous. It's just floppy and just waiting to break. So what I've done is I've made that so it's hardwired into this, so you don't have to keep disconnecting it all the time to get your blown battery out, which originally that was plugged into your batteries, your battery pack. So you know, just the way that that's put together, it's just ridiculous, and I thought, nah, no way. And I've just got my Dean's connector here. I'm just waiting on a bit of heat shrink so I can shrink that on, and it's all good, but it's pretty safe. Yeah, what else have I done? So that's the battery mod. So you just got your 6 screws here. Oh, I wanted to show you the other thing was the mod for the actual transmitter itself, the transmitter module. There's 2 ways to do the fix for the resistor fix for the trainer port. So when you plug your trainer port, you can run it with a also we'll run it through a simulator for a start, and I've got this set up on Phoenix RC. You might have seen that on YouTube. But also so that you can actually connect it up to a learner pilot and teach them how to fly and take control with your trainer switch when you when you need to do so, and save the heli from crashing to the ground, or the plane, or whatever you're using. So I just want to quickly rip this off. It's just a couple of bolts, and I'll just come back to you in a minute. Okay, so I've still got this hardwired, so you disconnect this from the unit, undo your 6 bolts, 1, 2, 3, 4, 5 and 6, and then take the top off. But before I do that, I'm going to show you the mod inside here, so I'll just quickly whip these 2 screws off. And what it is, it's basically designed to interrupt the signal between the module so that you can actually get it to communicate with something else. Otherwise it's continuously sending a ppm signal. So we'll just pull this out carefully. It's got a cable connected to it for the aerial, so okay, we'll just carefully take that back. And I just want to show you inside here. I won't pull it right out, but if you have a look in here, there's a little you can do it inside the actual transmitter itself, but I thought, oh hey, why bother doing that when you can do it in here. Okay, so that's the cover that's off, just 2 screws. Now what I've done is, I don't know if you can see this too well, I'll try and get a pointer, but in here you'll see a trace running from there to there. Okay, now that's your bind button. Okay, now I have cut that trace through there, and I've put a resistor between the 2 points that it was, so that will basically cause a break, technically a break in the circuit, so that the system thinks it hasn't got a connection. So yeah, it just cuts the voltage right back. So yeah, you've got to actually get a hobby knife or a cutting knife. Don't use a screwdriver or anything butcherous like that. And then just cut a little V in that section there, just as I've done there. And then to test to make sure that you've got it sorted, make sure that you want to put your own meter. I'll just quickly do it and show you. Put your own meter. Get this, if I can get this rigged up without falling over. Get your own meter here. Turn it to ohms. Oh, turn it to ohms. And what you want to do is you want to get a 0 reading. I don't know if you can see both of those at once, it's a bit difficult. Anyway, I'll give it a go. So what, I can't do it now because I've actually connected it up, but what you're going to do is put one connection on here, and the black one, well, it doesn't matter which way it is. Oh, excuse me. Let's see if I can get it to on here somehow. Yeah, there we go. And what I'm going to do is I'm going to put one point on here, on this connection here. Make sure you don't touch that one, just one, and also on this one here. And that's a 1 kilo ohm resistor, if you can't see that, basically. Which basically it's a big resistor. It's the only one I had, but you can even make a couple of little cuts in here and put a little SMD, like surface mount resistor in there if you like. You can buy hundreds of them for a couple of bucks. But this is what I had in my little box of bits, and so that's what I chucked in. Between the two you should have an open circuit, and that's how you make sure that you've cut that link, otherwise it ain't going to work. Okay, so we just put that back together again. Be careful not to strip the screws. You don't have to do them too tight. You just have to nip them up basically, because you know it's not holding anything, it's just holding the cover on. Make sure that it works. And when you put if you can see the coax cable here for the aerial, you've got to be careful when you put it back in, and you've got to line it up these 4 prongs here. And doing this resistor check, cut and putting the resistor in actually breaks the power feed coming from one of these leads. I think, pretty sure it's the end one here. But anyway, so when you put it back in, you've got to carefully feed that cable back into the hole, otherwise you'll end up getting the like crushing your cable, and it won't last too long. And you just click it into place like so. Okay, so we'll flip it open, and I'll show you what I've done on the inside. Well, there goes all my screws. Okay, so carefully put it across. I'll get the meter out the way now, so you don't need that. Okay, and just carefully, you don't want to like put too much strain on any of the cabling on these things, because they don't like it at all. So I'll just hover one over the top of the other, put all the levers down, and you want to pull this plug out here, this one. Try not to do not pull the cables themselves, because they will pull out of the actual plug itself. Just give it a wriggle end to end. Sometimes you need two hands to get in there, which I will, and just carefully pry it open like that, and yeah, voila. Okay, so there's the little plug there that I've gone that goes through the two holes here, and I've wired it direct onto the power plug for actually charging it. And originally there used to be a set of wires, I've replaced them, from there to those two. I don't know if you can see those two little wires that I've cut off there, right there. There's a red one and a black one right there. They're gone. I've cut them off, alright. Because there's a diode there. You can see the diode representation right there. There's a diode that runs across there, and that prevents it just won't charge. So I've basically cut that off, gone away from the board and gone straight back to what I want to do, and that's charge the blooming thing. Yeah, and that seems to work pretty good, real good actually. Okay, so next, I've got tutorials on that as well. Next is the fix that I've done for programming my USB ASP controller for doing your ER9X or Gervin, whatever you want to put on your software upgrade. I've got tutorials on how to do this, but what I've done is, it might look a little messy, but it actually is quite functional and insulated, which was the point of getting it kind of looking a bit like that. And I've actually used super glue as well to glue this 10-pin male plug-in, and then I actually have another plug that I plug inside that while I'm using it to stop dust and rubbish getting in it. But basically my USB controller, my USB ASP controller for doing your programming, and using EP for doing your model changes and copies, pastes and saves and all that sort of stuff, you just plug straight into there and you're away. You don't have to worry about powering up your unit. It powers everything up for you, and it's away. So yeah, that's pretty much it. The only thing I've got left to do, I know you can see these wires here off, and I've got them off for a purpose, and that's your backlight. And what I'm going to do here is, if I can get in closer, I may not be able to, resistor, that's right there, and that needs to be, I'm actually going to remove this because I've gone to my 2-cell lithium ion upgrade. Basically my voltage has come down from 12 volts to full voltage will be 8.4 basically, or 8.6, and it'll run probably around 7.5 roughly most of the time, 7.4, and then shut down. I've got my alarm set for 7 or 6.8. But this basically goes from running 8 AA batteries, which cost a fortune, and they take ages to charge them all up. I've got bucket loads of those, and I gave up on that because it's such a pain. They only lasted 3 hours. This setup here lasts for 10 to 12 hours, which is great. Not that you can fly for that long, but if you're mucking around with your settings and stuff like that, you don't want to get it all set up and then, oh great, I've got to charge the blooming thing. Okay, so yeah, so what I'm going to do here, because I've lowered this to a 2-cell 7.4 volt, it's designed to, this LED from Hobby King, LED backlight kit that I've put on here from Hobby King, it's running a little bit lean on light. It's not as light as it could be because it's designed for 12 volts. So what I'm going to do to fix that is I'm going to take out this 480 ohm resistor here, which I'll do when I'll get them. I've ordered them from the States, because it's just not worth buying them in New Zealand, unfortunately. Everybody just wants to make bucket loads of monies, and I've bought 250 of these surface mount resistors, including freight. It was like $3. Not that I'm going to use the other 249, but for $3, why would I bother hunting anywhere else? I don't even have to drive and burn any gas or wear any tyres out. It just turns up. Okay, so what I'm going to do, I'm going to change that out from a 480 ohm to a 360 ohm, which will basically decrease the resistance, which will allow a bit more current and voltage to flow through the LEDs in the backlight kit in the back here, which is underneath this board, and I'll get a much brighter setup. And also doing this resistor, I'm actually going to be putting in doing a couple of other things to this little board here to make it so that you can, with your ER9X, turn the backlight off, or get it to energize for a certain amount of seconds when you're pressing a button, kind of like when you've got a phone and you press the button and it all lights up, and then if you don't touch it for 30 seconds or whatever the program is set for, it'll turn off and save your battery life. So what's the point of watching the screen and having it lit up, wasting power if you don't need to? I mean, once you're up and flying, you're not going to be looking at the screen unless you've got telemetry or something set up on it. But anyway, yeah, so that's basically it, and that's really secure in there, and it's quite tidy, reasonably tidy. You can't do much better than that, I don't think, but I thought I did a reasonably tidy job. And I've just used hot glue gun like to seal it all off as much as I could, and then insulated all my wires and everything with glue gun. If I had have been a little bit more professional, I guess I could have bothered spending $5-10 to buy a bit of 30mm heat shrink tube and put it over there and shrunk it down, but it does the same job with hot glue, so who cares? At the end of the day, all you're trying to do is stop shorting. So hey, why waste money when you got the hobby stuff? So cool. Okay, well, thanks for watching, and hopefully that's given you some idea of what's some of the things you can do with this cool little unit. Oh, one other thing I noticed, I was getting a bit PO'd with the screen here, is because I thought, oh, this is just ridiculous. The screen's like really easy to scratch, because I thought, hang on, and I gave it a bit of a with my fingernail, and it's got easier and easier to scratch. So this is ridiculous. Anyway, it's actually a film that's over top of it, so it's a bit of a protector, which I actually might put a bit of more clear on here and protect the screen for a bit longer to keep it looking nice and new. But yeah, apart from that, man, she's a pretty good unit. I love it. Excellent. Cheers, guys.